Hello guys, today we will present about Lab 5 Basic Logic Gates, Truth Table and Circuit Analysis. First of all, my name is Atika BINTI GHANI with my matric numbers is B0920100047 and my partner's name is NONNY ANAK UMPING with matric numbers is B0920101166. Okay, we will present about basic logic gates and so we go to the introduction first. Okay, logic gate is the most basic type of digital circuit which consists of two or more inputs and one output. It has only two states, either 1 or 0. A gate can be used alone to perform a logic operation or function. It can also be connected or linked to several other gates to form a logic network. There are several examples of logic gates. First is NOT gate, OR gate, AND gate, and OR gate, and AND gate, XOR gate, and XNOR gate. This is NOT gate and the symbol. NOT gate it has one binary input and one binary output. The NOT gate output is the inverse of its output. If A is false, Y is true. NOT gate will implement logical operator not corresponding truth table. Next, OR gate. It has two binary input and one binary output. The OR gate produces a true output if either A or B or both are true. OR gate will implement logical operator addition with corresponding truth table. Next is AND gate. It has two binary input and one binary output. The AND gate produces a true output, Y if and only if both A and B are true. Otherwise, the output is false. OR gate will implement logical operator multiplication with corresponding truth table. Next is AND OR gate. AND OR gate is the combination of OR and NOT gate. This produces true output when all of the input is false and produce false output when any of the inputs are true. Next is AND gate. This combination of AND and NOT gate and produce true output when any of the inputs are false. Produce false output when all of the inputs are true. Next is XOR gate. A digital logic gate with two or more inputs and one output that perform exclusive disjunction. The output of an XOR gate is true only when exactly one of its inputs is true. If both of an XOR gate's inputs are false, or if the both of its inputs are true, then the output of the XOR gate is false. If an XOR gate has more than two inputs, then its behavior depends on its implementation. In the vast majority of cases, an XOR gate will output true if an odd number of its inputs is true. Next is XNOR gate. A digital logic gate with two or more inputs and one output that performs logical equality. The output of an XNOR gate is true when all of its inputs are true or when all of its inputs are false. If some of its inputs are true and others are false, then the output of the XNOR gate is false.
Salam sejahtera. I'm Nonni and UMPING from BMMV S2-1 with metric number B0920101166. Okay, today I'm gonna make a simulation process for our part A. The first IC type I'm gonna use is 7408 IC. Before I start with the simulation, I'm gonna place the component that is needed. Mm, VCC type of power sources. The next one is the IC 7408 IC. Next is the input. As for the input, I'm choose switch SPDT type of switch. And for the output, I'm choose yellow LED diode. Okay, the last one is ground. Before I start to connect all the component, here I want to explain what is the function of each component here. The VCC here is the power source. The switch here is the SPDT type switch here is an input, S1 as input A and S2 as input B. When the switch in turn on, the input is 1. And when the switch is turned off, the input is 0. And for the output, I choose yellow LED diode. When the yellow LED diode is turned on, the output is 1. And when the yellow LED diode does not turn on or turn off, the output is 0. And this one is the IC 7408 IC. Okay, I'm gonna connect all the component. Okay. Okay, next I'm gonna run the circuit so that we can see what happened to the output when the input A is 0 and input B is 0. The output is 0 because the yellow LED does not turn on. And when the output A is 0 and output B is 1, the output still 0 because the LED does not turn on. And when the input A is 1 and input B is 0, the output still 0 because the LED still does not turn on. But when the input A is 1 and input B is 1, the output is 1 because the yellow LED turn on. Next, for the next IC type, which is 7432, I just need to replace this IC here to 7432 IC. Just type it in here, 7432 IC. Okay. Okay, the step to run the circuit is the same with the first one, same with the 7408 IC. As an example, when the input A is 0 and input B is 0, the output is 0 because the yellow LED does not turn on. And the same thing goes to the when the input A is 1, input B is 0, or when input A is 1 and input B is 0, the step to run the circuit is the same with the 7408 IC. Okay, that's all. Thank you.
So we go to the part B. I will show the simulation for the part B. First, click at place and then component and then search for not gate with using the code is 7404. Then click OK. I put here and another one I put here. Next, search for the AND gate. The code is 7408. I put here. Then next I search for OR gate. The code is 7432. I put here and another one I put here. Next I search for the AND gate. The code is 7400. I put here. Thus, we search for the AND gate is the code is 7402. Then I put here. Then search for LED. Use LED blue. I put here. And next we connect with the ground. Okay. Then click at digital source and click at interactive digital constant. I put here. I put 4 because it has 4 inputs. Then I label with A, B, C, and D. Then connect to the logic gate. Then connect with LED. Next to the ground. So we can run the simulation. If the diode not light or not color, it means the simulation is zero. If the LED color with blue, because we use LED blue, it means it can run. It means it's fine. Okay, this is the Boolean expression for the part B. Okay, for the conclusion, there are 7 types of logic gate, which is AND gate, NOT gate, OR gate, and OR gate, and AND gate, XOR gate, and XNOR gate. Each of logic gates produce different output even though the value of input is the same. As a result, the experiment was a success, where whereas we learned that logic gate can be implemented using electronic components and use the multisim software to identify the operation of logic gates. So that's all from me. Bye bye.